Right, so solving these ones, Hunter, you said the answer was x equals -8 or x equals 4. And I asked you, what do they represent? And your answer was the x-intercepts of this, what? What type of graph is that? Yeah, so if we had the y equals x plus 8, x minus 4, if we had that as an equation, that would be a parabola, right? Because if we expanded it out, we would get x squared minus 4x plus 8x minus 32. And that's what we would get. Or more importantly, you'd probably get x squared plus 4x minus 32. And so that graph there, if we factorize it, looks like that. And because now what we can do is we can make y equals 0, we can solve for these two x-intercepts. Okay? Everyone happy with that? How did you get -8? How did you get 4? Great, thanks.
Because we got the 8 on the right side of the bracket and the -4 on the right side of the bracket.
Not quite. How do you get this answer here of -8?
Well, in one bracket, if you make x -8, then -8 plus 8 is 0, and 0 times anything is 0. Yeah.
So you are making the brackets equal to 0. That's what you're doing. Okay? Everyone happy with that? And with those ones there, it's probably quite easy to see, but the last couple might not be as easy to see. Because 0 times anything is 0. Now, if I was going to get you to draw that graph, what would be the next thing you could do? Okay, y-intercept and the vertex. Those are the two things you need to do. So I asked you one thing, you gave me both. Put it away. How would you find the vertex?
By expanding it and then...
Nope. You don't have to. You could. But the rest of the class don't know how to pick a square. So how do you do that?
Find the middle. Yeah,
find the middle. Where's halfway between those two x-intercepts? That'll be where the vertex is, because parabolas are symmetrical. So -2 is in the middle, isn't it?
Yes.
Because it's 6 that way and 6 the other way. Happy with that? And so how far down is my vertex? 32. No? 36. Why 36? Because I go over 6 and I'm going down 6 squared, which is down here at 36. Okay? I'm not going to get you to draw that graph because that's quite a waste of paper. But that's what you're going to do. Okay, that's where we're going today. That's where this vertex method, this root method's going. Second question here. What are my two x-intercepts, please? Blake. This one here. You, Blake.
I'm actually not too sure.
What did Finian say?
0 times 0.
And he said make the bracket 0. So what number of x makes that first bracket equal to 0?
2.
Yeah. So x equals 2 or... Yeah. There are my two answers. X equals 2 or x equals 9.
Yeah.
They're my two answers. What have I found? My two x-intercepts here at 2 and at 9. Okay. What have I also found? The vertex, because the vertex is going to be halfway between 2 and 9. What is halfway between 2 and 9? How'd you get 5.5? Yeah, half. So you can either go 9 minus 2 and then half that. And then you go, well, that's 3.5. So I'm going to add 3.5 to 2. Or you could just go 9 plus 2 divided by 2. That would actually give you the actual answer. But we'll go through that shortly. Next one. Jacoby, what are my answers here?
Positive 3 and 0.5 for a half.
Can everyone see why the answer is 3? Some of you looking blankly. Can you understand why it's 3, Ryan? Right? Can you understand why it's 3?
Because it's taking away 3 then it equals 0.
Because
3 take away 3.
3 take away 3 is 0. Okay? And why is it a half? Because 2 lots of 1 half is 1 minus 1 is 0. Okay? What does that tell me? My 2 x-intercepts are there at a half and 3. What does this part here tell me for my graph? It's an upside down graph. Okay? There's going to be the general shape of my graph. And the last one, what are my 2, or do I have 2 answers there?
Yep.
Pardon? Jay, what are my answers here?
X equals 0
X equals 0.
or X equals minus 2, divide 2.
Yep. Negative 3 over 2. Why is it 0?
X at the start.
Because the X at the very front of the bracket, and that would be 0 times anything would be. So if that one there, that graph would actually go through the origin just there, okay? Okay. So this is the stuff we're going to start doing now. We're going to start to, yesterday we had a real quick look back at solving quadratics. Okay. Shortly we're going to extend that on to drawing quadratics that look like either that or look like that. In other words, look like one of these 2 styles here. Okay. Any questions with that? All right. So